Hi children, welcome to my class Electric Current Part 1. In this class, you will learn a brief introduction to electric current, what is meant by electric current, what are the units of electric current, what is electrical potential energy. We will learn in this class Electric Current Part 1. Children, we are all living in the modern world. At present, the world is driven by electricity. See this computer, electric bulb, fridge, air conditioner, and the fan. All these are driven by electricity. Without electricity, we cannot imagine our life for a single minute. Let us learn what is electricity, how it flows from one point to another point, what are the units of electricity in this session. Electricity. Electricity is the branch of physics which deals with the electric charges. The branch of electricity which deals with the charges at rest is known as static electricity. At the same time, which deals with the charges in motion is known as current electricity. So, static electricity means the branch of physics which deals with the charges at rest. Current electricity means the branch of physics which deals with the charges in motion is known as current electricity. As you know that there are two types of charges are there. One is the negative charge, other one is the positive charge. Next, like charges repels each other and unlike charges attracts each other. Like charges in the sense positive positive, negative negative. At the same time, unlike charges means positive and negative. There is always attractive force between unlike charges. Who carries the positive charge? As you know that the fundamental particle protons carries the positive charge. Next, the fundamental particle electron carries the negative charge. Children, see the adjacent diagram. The basic nature of metal is its atom consists loosely bonded electrons. Due to the tiny energy, a little bit of energy, these electrons can be detached at any time. These electrons are known as free electrons. These free electrons move randomly. Observe the random motion of the free electrons in the metal when it is not connected to the external electric field. See, they move randomly colliding with the atoms. See this one, the random motion of the electrons in a metal when it is not connected to the external electric field. You observe this diagram. When a potential difference is applied at the ends of the two ends of the conductor, a uniform electric field is set up. When these free electrons when these free electrons comes under the electric field, an electric force acts on the free electrons. See this one. This is the direction of the electric field, whereas the free electrons are moving opposite to the direction of the electric field. The force acting on the free electrons by the electric field F is equal to Q into E. You observe this one. This is the directional motion of the electrons which are moving from negative terminal to positive terminal of the battery. This electric field applies the force on the electrons to move in a single direction. This orderly motion of the electrons is known as electric current. What we call it? Electric current. So, what do you mean by electric current? Electric current is the orderly motion of electrons in a single direction. Children, we learnt current is the orderly flow of electrons. So, current is defined as charge passing through a cross section of a conductor in unit time. So, I is equal to Q by T, where Q stands for charge and T stands for time. What are the units of current? Ampere. So, if 1 coulomb charge passes through a cross section in 1 second, then the current is 1 ampere. You know that 1 coulomb means 6.625 into 10 to the power of 18 electrons. So, this is all about current. Now, current is nothing but flow of charge. Flow means it should have the starting point and the ending point. As you know that water flows from high level to low level, and air blows from high pressure area to low pressure area, and heat flows from high temperature to low temperature. In the same manner, how the current travels, what is the direction of the current? Current always travels from high potential to low potential. High potential to low potential. What do you mean by high potential? See this point A, consider this point A. Here there are more positive charges are there. More positive charges in the sense there are less number of electrons. Here at point B, more electrons are there. More electrons are there. So the point where more positive charges or less number of electrons are there is considered as high potential point. Next, the point where more number of electrons or less positive charge lies is considered as low potential point. You see, in olden days, before the discovery of electron, it was assumed that the positive charge flows. So, the direction of the flow of positive charge is considered as the direction of the current. This is known as conventional current. At the same time, after the discovery of electrons, the only charged particles which flows are nothing but electrons. So the flow of electrons is considered as electronic current, and the flow of positive charge is considered as conventional current. Next, you observe this situation here. See this. Here it is the positive charge, means high potential point. Here it is all negative charges, means low potential point. See, electric field is applied here. Electric field is applied here. Now, if you want to move this positive charge towards the high potential point, certain amount of work is to be done. Work is to be done. This positive charge is kept within the electric field. Within the electric field. When the positive charge is kept in the electric field, this charge has some electrical potential energy. So the potential energy which a charged object has when placed in electric field is known as electrical potential energy. So this is equal to, what is that? It is equal to the work done to move this positive charge against an electric field. Okay, so if you want to move this positive charge against to the electric field towards the high potential point, you have to do some work. You have to do some work. That work is nothing but electric potential energy. What we call it? Electrical potential energy. Thank you, children. If you like my video, please subscribe to my channel and don't forget to watch my lessons. Thank you.